When we look at the universe, we see stars, planets, and galaxies floating in the vast emptiness of space. But what if I told you that what we can actually see, what we can actually touch, measure, and understand, makes up only a tiny fraction of the cosmos? Most of the universe is made of something completely invisible, something we can't detect directly, but know it's there. It's called dark matter, and it's one of the greatest mysteries in modern science. In this video, we will explore the mysterious world of dark matter. We'll talk about what we know, what we don't, and how scientists are trying to solve this cosmic puzzle. So, let's dive in. What is dark matter? To understand dark matter, we first need to understand what the universe is made of. Everything we know, everything that forms the planets, stars, and even you and me, is called normal matter, or baryonic matter. It's what makes up around 5% of the universe. The rest of the universe is something else, something we can't see. About 27% of the universe is made of dark matter, and the remaining 68%, that's dark energy, a different mystery for another time. But what exactly is dark matter? Here's where things get tricky. Dark matter doesn't emit, absorb, or reflect light, which means we can't see it directly. It doesn't interact with the electromagnetic force, making it invisible to the entire electromagnetic spectrum. Radio waves, light waves, X-rays, you name it. So, if we can't see dark matter, how do we even know it exists? How do we know dark matter exists? The first clues about dark matter came in the 1930s when Swiss astronomer Fritz Zwicky was studying a group of galaxies in the Gamma cluster. He found something strange. These galaxies were moving way faster than they should have been. Based on the amount of visible matter, the galaxies should have been flying apart, but they weren't. Zwicky concluded that there must be some kind of invisible mass holding them together. He called this dunkle materie, dark matter. Fast forward to the 1970s, and Vera Rubin made a groundbreaking discovery when studying the rotation of galaxies. She found that the outer edges of galaxies far from the center were moving just as fast as the stars near the center. According to the laws of physics, this shouldn't happen. The galaxies should be ripping apart. There simply wasn't enough visible mass, stars, gas, and dust, to produce the gravitational pull necessary to keep them intact. This strange behavior could only be explained if there was something else, something unseen providing additional gravitational pull. That something is dark matter. The role of dark matter in the universe. Now that we know dark matter is here, let's talk about its role in the universe. Dark matter acts like a cosmic glue. It provides the extra mass needed to explain why the galaxies stay together and why galaxy clusters don't fly apart. Without dark matter, the universe as we know it wouldn't exist. Galaxies wouldn't form. Stars wouldn't stay in their orbits, and the large-scale structure of the universe wouldn't look the way it does today. In fact, dark matter played a crucial role in the formation of the universe after the Big Bang. As the universe expanded and cooled, dark matter clumped together to form a cosmic web. Filament-like structures of dark matter that span across the universe. These filaments act as the scaffolding on which normal matter gathered, eventually leading to the formation of galaxies, stars, and planets. So, dark matter isn't just an individual mystery floating out in space. It's responsible for the structure of the universe itself. What could dark matter be made of? Now, for the million-dollar question, what is dark matter actually made of? This is where things get speculative because despite all the evidence that dark matter exists, we still don't know what it is. Scientists have come up with a few leading theories. One of the most popular is that dark matter could be made of something called WIMPs, weakly interacting massive particles. WIMPs are hypothetical particles that don't interact with normal matter except through gravity. They are massive enough to explain dark matter's gravitational effects, but difficult to detect because they rarely interact with anything else. Another possibility is that dark matter could be made of axions, ultra-light particles that have been theorized but never observed. Axions would behave differently from WIMPs. but could still provide the gravitational influence that dark matter seems to have. There's also a theory involving sterile neutrinos, a type of neutrino that doesn't interact with normal matter except through gravity. Sterile neutrinos could be the dark matter particle we're looking for, but like WIMPs and axions, they haven't been observed yet. Why is dark matter so hard to detect? If dark matter makes up 27% of the universe, why haven't we detected it directly? The problem is that dark matter barely interacts with normal matter. It doesn't produce light, it doesn't absorb light, and it doesn't collide with atoms in the way we might expect. It's essentially invisible to our current methods of observation. Scientists have been trying to detect dark matter for decades. There are underground laboratories with detectors designed to catch this rare interaction between dark matter particles and normal matter, but so far none of these experiments have produced definitive results. This leaves us with indirect evidence, like the movement of galaxies and the gravitational effects we observe, to tell us that dark matter exists. Could dark matter be something we haven't thought of? What if dark matter isn't made of WIMPs, axions, and sterile neutrinos? Some physicists have suggested that dark matter could be something entirely different, something we haven't even thought of yet. There's even a possibility that dark matter doesn't exist at all and that our understanding of gravity is incomplete. Some alternative theories propose that the laws of gravity behave differently on cosmic scales, but these ideas haven't gained wide acceptance. While scientists are continuously exploring these possibilities, one thing is clear. Something out there is affecting the universe in ways we don't fully understand. The future of dark matter research. So, what's next in the search for dark matter? The hunt is still on. Scientists are building more sensitive detectors, launching new space missions, and improving our understanding of particle physics to solve this mystery. The Large Hadron Collider, LHC, at CERN is one place where scientists are looking for dark matter. By smashing particles together at high speeds, researchers hope to create conditions where dark matter particles might be produced or detected. There are also experiments deep underground, where detectors are shielded from cosmic radiation in hopes of catching a glimpse of dark matter. In the coming years, new space-based observatories like the Euclid mission and NASA's James Webb Space Telescope could provide more clues. These powerful tools will allow us to map the distribution of dark matter across the universe more accurately, potentially revealing new insights into its nature. The cosmic mystery continues. As of now, dark matter remains one of the most tantalizing mysteries in science. We know it's out there, shaping the universe, but its true nature eludes us. Will we ever find out what it's made of? Will we be able to detect it directly? These are the questions driving scientists to keep searching, to keep pushing the boundaries of our knowledge. The universe is a vast, mysterious place. Dark matter is just one of the many puzzles waiting to be solved. And as we continue to explore, who knows what other secrets we might uncover along the way. Dark matter may be invisible, but its impact on the cosmos is undeniable. The mystery may be far from solved, but every step we take brings us closer to understanding the hidden forces that shape our universe. If you enjoyed this video and want to learn more about the mysteries of the universe, don't forget to like, subscribe, and hit that notification bell. We have more exciting content lined up that dives into the wonders of space, science, and the unknown.